Okay, so this lesson is over review over what you guys should have touched on last year. All right, so the first thing that we wanted to go over is a plan for problem solving. So when you're looking at a plan for problem solving, there are 4 steps that you want to take. You want to understand, you want to plan, you want to solve, and you want to check. When you understand, you want to do things like ask what facts do you know? Ask what do I need to find out? Ask is there enough information to solve the problem? And is there extra information that I don't need? Then you want to plan how you're going to solve it. The biggest thing there is to make a plan and choose a strategy for solving it. There may be several strategies that you can use, and we're going to go through a few of the different strategies. The other thing that you could try to do is to estimate what you think the answer should be, and therefore you can, when you get your answer, see if it makes sense, okay? So then you can solve. So you use the plan to solve the problem. If the plan does not work, revise it and make a new plan, okay? And then lastly, you want to check. So you can take a look and ask questions like, is my answer reasonable and close to my estimate? Does my answer make sense? That's the big one. If you get something that's like if you're looking for the size of a tree and you get, 2,000 feet, it's probably not the right answer. It doesn't really make sense, okay? So those are the 4 steps that you want to go over. So let's look at that in practice. So this problem says use a 4-step plan. A school sells 4 different clothing items in any of the 3 school colors, as shown in the table. Use the 4-step plan to find how many different item color combinations are possible. So the understand piece, we know there are 4 clothing items, and we know there are 3 possible colors. And we need to know how many combinations are possible. So then we plan, how are we going to solve this? So we can use the information in the table and we can make lists of possible combinations. So we use this information right here and complete the combinations. So we could list out cap, blue, cap, gold, cap, white, jacket, blue, jacket, gold, jacket, white. Same thing for sweatshirt, same thing for t-shirt. Then all we have to do is simply add up how many different combinations. So 12 different combinations are possible. And then for the last step, for check. To check this, all we'd have to do for this example would be solve it in a different way. In this case, we start with the colors. So we have blue cap, blue jacket, blue sweatshirt, blue t-shirt. We do that for the white, and we do that for the gold, and then count up, and we still have 12 different combinations. So therefore, we know that we're correct, that it's 12 combinations, okay? So that's the 4-step plan to solving a problem. All right, so let's look at some different strategies. The first strategy we'll go over is called look for a pattern, okay? When you use a strategy, you're going to analyze the first few numbers in a pattern to identify a rule that is used to go from one number to the next. Then use the rule to extend the pattern to find the solution. So for example, Raymond got an email from Angela. After 10 minutes, he forwarded it to 2 of his friends. After 10 more minutes, those 2 friends forwarded it to 2 more friends. If the email was forwarded like this every 10 minutes, how many people received Angela's email after 40 minutes? So understand, you know how long it takes to forward an email, and you need to find the total number of people who received the email. So we're going to plan. We could organize the data in a table, okay? That's what they did right here. We can look for pattern in the data to extend the pattern. So if we take a look at this, we can see that going from 1 person to 2 people, we times 2. Going from 2 people to 4 people, we times 2. So if we continue that pattern on from 4 people to times 2 would mean there would be 8 people. And then times 2, there would be 16 people. So we could continue that, and we could follow that and plug that in the table, and that would be 8 people and 16 people. Now, we want to know how many got the entire email. All we'd have to do is add it all together, and that gives me 31 people got the email. Okay? And then to check it, we know that in the 40th minute, 16 people received the email. Half as many people received it the time before that. So is it reasonable that the total will be less than 16 times 2 or 32? Yes. Okay? So therefore that works. So that's just looking for a pattern. Okay? Now, another strategy that we can use is called guess and check. So you can use this when the results, you can then use the results to improve your guess, until you find the solution. This strategy is called guess and check. Each hand in the human body has 27 bones. There are 6 more bones in the fingers than in the wrist. There are 3 fewer bones in the palm than in the wrist. How many bones are in each part of the hand? So we can make a guess to find the bones in each part of the hand. Okay? So we could set up a little table here. We know that it tells us that there's 27 bones total. So we could put a category of 27 bones. Then it says there are 6 more bones in the fingers than in the wrist. So we can put a category wrist plus 6. And then we know there are 3 fewer bones in the palm than in the wrist. So we could put that category. Then if we knew how many were in the wrist, we could easily solve this. But since we don't know how many's in the wrist, we have to guess. Okay? So for example, if we guessed 5 in the wrist, 5 minus 3 is 2. 5 plus 6 is 11. We add those together. 5 plus 2 plus 11 is 18. 18 is not 27, so it's too low. And we could keep doing that until we narrow it down, until we find the right answer. In this case, it's 8. 8 minus 3 is 5. 8 plus 6 is 14. 8 plus 5 plus 14 is 27, which we know there's 27 bones. So therefore, 8 has to be the right answer. So there are 8 bones in the wrist, 5 bones in the palm, and 14 bones in the finger. So this is how you can make a guess. So if you first originally read that problem and went, I don't have enough information because I don't know how many are in the wrist, that's how you just start guessing what's in the wrist until it solves and you find out the correct one, which works. Okay? All right. Let's see. Another strategy we could use is called make a table. A table allows you to organize information in an understandable way. So let's look at an example. A vending machine accepts dollars, and each item in the machine costs 65 cents. If the machine gives back only nickels, dimes, and quarters, what combinations of the coins are possible as change for $1? So we know that the machine will give back $1 minus 65 cents or 35 cents in change in a combination of nickels, dimes, and quarters. So we can make a table. We can say quarters, dimes, and nickels. And we need to get a total of 35 cents, okay? So we could start with quarters. 1 quarter would be 25. A dime would be 35. We could try quarters again. 1 quarter and 2 nickels would be 35 cents. Nothing else we can do with quarters, so we go to dimes. 3 dimes and 1 nickel. Then 2 dimes and 3 nickels. 1 dime and 5 nickels. Then we go to nickels, 7 nickels. Then all we have to simply do is count it up. 1, 2, 3, 4, 5, 6. So there are 6 possible combinations. Okay? So that's how making a table can help you solve a problem. All right. Let's see. I believe there's another one. It's called work backwards. Okay? So this is basically when you're giving the end result and they're wanting to know something like how much you started with. Okay? So you can use the work backwards strategy to start at the end result and undo each step. So let's take a look. It says Kendrick spent half of the money he had this morning on lunch. After lunch, he loaned his friend $1. Now he has $1.50. How much money did Kendrick start with in the morning? All right. So we know that we start with the end. He ended with $1.50. Now we work backwards to find out the starting amount. So the last thing he did was he loaned a friend $1. So we have to add back in that dollar. Now we have $2.50. Now we know before that, when he had a start of money, he had spent half of that on breakfast. So when he spent half of that, that means we divided the total number by 2 to get the half of it, okay? And that's 250. The opposite of division is multiplication. So we could simply multiply 250 by 2, and that gives me $5. So the amount Kendrick started with was $5. Now we can check that. We could go in reverse. So he started with 5. He spent half on lunch. So if he spent half, now he's down to $2.50. He gave his friend $1. Now he's down to $1.50, which is exactly what they said he had left. So therefore, the $5 must be the correct answer. Okay? So that's working backwards. Now, let's go through number and operations. A decimal is a number that has a digit in the tenths place, hundredths place, and so forth. You can add and subtract decimals. Line up the decimal points first. All right, so let's take a look. So this problem says the table shows the scores for each event for the top 2 finishers of the 2009 Southeastern Conference Gymnastics Championships. We have Courtney and we have Morgan, and it gives their event scores for each event. And it says to find the all-around score for each champion. So we could list all of Courtney's scores, and we could list all of Morgan's scores. Now you will see that, for example, on Morgan, 9.825 and 9.8. We would have to add or annex a 0 to align the columns. So we'd put a 0 in, we'd put a 0 in, so that all of our columns are nice and straight. We keep our decimal straight in the row, and that tells us where our decimal should be, okay? And then we just simply add straight down, and that would give us our answers, okay? Then it asks you how much greater was Courtney's score than Morgan's. So we're subtracting the two. Again, you have to keep your rows straight where they belong, and so the decimal goes straight down, and that would show you where your decimal goes. So in this case, Courtney's score was 0.25 more than Morgan's, okay? So that's how you add or subtract with decimals. Now, let's talk about multiplying with decimals. When you multiply with decimals, remember that however many spaces there are to the right of the decimal on each factor, the product is going to have that many. So each one of these is a factor, okay? So in this one, there's one space to the right of the decimal. This one, there's one number to the right of the decimal. So the answer has to have 2 decimals to the right of the decimal, okay? So that's how I know where to put my decimal. All right. Division works a little bit different. So in this case, we want to divide 0.086 divided by 0.04. Now, we want to make sure that we're dividing by a whole number. So we need to multiply to get this decimal over. Well, we can multiply by 100, and this would move it over 2 points. If we do it to that number, we have to do it to this number. So therefore, that becomes 8.6 divided by 4. Now, when you divide this, you just start each term. So how many times can 4 go into 8? 2 times. That gives me 8, which would be 0. I then bring my 6 down. But you see this decimal right here. So now we have the decimal right there, okay? So we just move the decimal in line with where it's at. And then I can continue working. 4 goes into 6 one time. 6 minus 4 is 2. We have to add or annex a 0, bring that 0 down, and now 5 goes into 4, or 4 goes into 25 times, and now I have 0. So that's how the decimal works with a division problem. So the quotient would be 2.15, or the answer, okay? All right, let's see. Let's look at a little bit of algebra. So, all right. So in this first problem, we need to write a rule. If you can write the rule, then you can solve for any figure. So it says write a verbal rule to find the number of dots in any figure below, then find the number of dots in the 15th figure. All right. So when we look at this, we can draw each figure. We can and look for a pattern and write a rule. So we can make a table to organize the information, which is what they did here. So for the first figure, we had 3 dots. For the second figure, we had 5 dots. For the third figure, we had 7 dots. So we kind of look for a pattern on what we have here. So we know that it goes up 2 times each one, okay? So we could say whatever figure times 2. Now if I did 1 times 2, that's 2, but I need to get to 3. So to go from 2 to 3, I would have to add 1. So let's say I did the second number. 2 times 2 is 4, but I have to be at 5, so plus 1 gets me to 5. 2 times 3 is 6, but I need to be to 7, so I have to plus 1. So this could be my rule, okay? A way you can write that is 1 more than twice the figure number. So now I can do any figure I want and know how many dots are going to be in it. How do I do that? I just plug in for n. So example, if I need the 15th figure, it would be 2 times 15, which would give me 30, plus 1 is 31 dots. So once I figure out my rule, I can solve it very, very easily. Okay? All right. Let's look at this one. It says find the 25th term in the sequence 4, 8, 12, 16. So again, I can make me a table. I can say the first term was 4, the second term was 8, the third term was 12, the fourth term was 16, and I need to know the 25th term. So I could keep going, keep going, keep going, or I can take a look that this goes up by 4, this goes up by 4, this goes up by 4. So I could write me a rule. I could say the term or the position number times 4. Now does that work? So 1 times 4 is 4, which is correct. 2 times 4 is 8, which is correct. 3 times 4 is 12, which is correct. And 4 times 4 is 16. So that's correct. So this could be my rule. And now for any term in this, I can just plug, for any number I could plug in there and find out what the value of the term is. So they're wanting the 25th. So it would just be 4 times 25 or 25 times 4, which would give you 100. Okay? So once you have the rule, then you can find anything you want to very, very easily in that problem. All right. Let's see. One more. So describe to find the number of diagonals that you can draw from any one vertex in the polygons shown. Then find the number of diagonals from one vertex in a 10-sided polygon. All right. So a vertex is where 2 points come together, 2 lines come together to form a angle. All right. So if we look at a 3-sided, there's no way that we could draw from one vertex to the next vertex, okay, a diagonal. If we look at a 4-sided, you could draw 1 from one vertex to the next. On a 5-sided, I could draw 2. Okay, so we could set that up in a table. So 3-sided is 0, 4-sided is 1, 5-sided is 2. And we're trying to find what a 10-sided would be. So we need to figure out what it is, okay? So when we look at this, we could figure out a rule that 3 less than the number of sides. So I can take whatever sides I have and subtract 3. Let's see. 3 sides minus 3 would be 0. 4 sides minus 3 is 1. 5 sides minus 3 is 2. So that rule works. So simply all I have to do then is go 10 minus 3. And that would equal 7. So I know that there are 7 diagonals on a 10-sided polygon. So again, once you find the rule, then the rest is pretty easy. All right, so looking at geometry, we're looking at perimeter. You all should remember perimeter. That's the distance around a closed figure. It's only length, And they find the perimeter by adding the measures of all the sides of the figure. So this first problem says the distance between each base on a Little League baseball diamond is 60 feet. Find the total distance you will run if you hit a home run. So what this is saying is if you start at home and you go to first, that's 60 feet. You go from first to second, that's 60 feet. You go from second to third, that's 60 feet. And you go from third to home, that's 60 feet. And you want to know the total that you would run, you would add each of those together, and you would get 240 feet. Okay? So that's perimeter. Let's look at another one. It says Layla is putting the letter shown at the right into a scrapbook. She wants to put a decorative trim around the letter. Measure the sides of the letter to the nearest millimeter to determine how much trim she will need. So in this problem, it's telling you to use a ruler, measure it out, and see what you got. They've actually done this for us. The longest side would be 21, and then I know these two sides have to add up to 21, so this would be 15, this would be 6, this would be 16, this would be 10, this would be 6, okay? So that's my perimeter. Now, if I want to know how much trim she needed, I just add all of those numbers together, and I get 74 millimeters. Don't forget the term millimeters, okay? So perimeter is just adding the sides on the out, okay? All right, let's take a look at measure. Measurement, when you look at measurement, you have two different measurements, mainly two measurement systems. You have the customary system and you have the metric system, okay? In the customary system, you have things like inch, foot, yard, mile. In the metric system, you have millimeter, centimeter, meter, kilometer, okay? So those are the things you have. So we could take a look and it says complete each conversion. We want to know how many yards are in 129 feet. 1 yard equals 3 feet. So we know the answer is going to be smaller than 129. Since it's going to be smaller, we are going to divide. So 129 divided by 3 would be 43, or 43 yards in 100 feet. If we go from, in this case, B, inches, want to know how many inches are in 4.5 feet, and there are 12 inches to 1 foot, then there's going to be the number, the answer is going to be greater than 4.5. So therefore, we are multiplying. 12 inches times 4.5 gives me 45 inches, or 54 inches. So 54 inches equals 4.5 feet, okay? Same thing with 13 centimeters to millimeters. Since millimeters is smaller than centimeters, we're going to have a bigger number, or we're going to multiply. 13 times 10 is 130. So there's 130 millimeters in centimeters. In D, we're going from meters to centimeters. Meters are larger than centimeters, so it's going to be a smaller number, so therefore we're going to divide. 175 divided by 100, 1.75. Okay? That's how you convert. All right. Let's see here. So lastly, we're going to look at some data analysis. We're going to look at some different graphs and tables. Okay. The first one is called a pictograph. You compare data by using picture symbols. Whenever you look at a pictograph, make sure you look at the legend and find out what each one means. So in this case, each one of those means 2 students. If you would have a half of one like this, that would mean 1 student. In this question, it says the picture graph shows the number of students in each homeroom that have their driving permit. How many times as great is the number of students who have their driver's permits in homeroom 16 versus homeroom 14, or as in homeroom 14? So we know that there are 4 in homeroom 14, and we know that there are 2, 4, 6, 8 in homeroom 16. And simply, if I just want to know how many times more there is I can divide. Divide 8 by 4 and gives me 2. Or there are 2 times as many, in room 16 than in room 14. And I can check that by just saying 4 times 2 is 8. Okay? All right. So the next one is a line graph. So in this line graph, it says we can use line graphs to show direction and trends of data, okay? So The line graph shows the growth of a baby Asian elephant at the National Zoo in Washington, D.C. Find about how much weight the elephant gained from 10 months to 12 months. So we could go from 10 months to 12 months. And at 10 months, we're at about 700 pounds, okay? And at 12 months, we're at about 900 pounds. So if I want to know how much it gained, I can take 900 minus 700, which gives me 200. And so the elephant gained about 200 pounds between the ages of 10 months and 12 months. Okay? So that's how I use a line graph. Then we have bar graphs, and it is used to compare categories of data. The height of each bar represents the frequency of each category of data. So, for example, the bar graph shows the approximate number of shopping malls in the states with the most shopping malls. About how many more malls are in California than Illinois. What I want to point out to you is it says about how many. So it's not going to be an exact answer. And the reason for that is if we look at California, we know that it ends somewhere between 6,000 and 7,000. So you have to look at where it is and try to predict what you think that number is. In this case, we're going to predict that it's 6,500. And then we look at Illinois, it's the same thing. We have to predict where it is between 2,000 and 3,000. So we could predict 2,250. You may predict 2,000. Well, the answer is going to be a little bit off. But remember, it's about, it's not exact. So in this case, then, if we're wanting to know the difference, we just have to subtract. And in this case, we would get 4,250. So there are about 4,250 more malls in California than in Illinois. Okay? So that's how you use bar graphs. That's the lesson. The homework is posted. If you have any questions, just let me know. Thank you and have a great day.